Normally, I'd put out a video like, Dad ruins smart speakers, and then I would follow that up, seemingly an eternity later, with a video that shows you how to implement an alternative to the thing that I ruined. Just ask anyone who's patiently waiting for the NVR videos I promised in my Dad Ruins Home Cloud camera video. I promise, I'm still working on them. Today, I'm going to flip it around as an experiment. We're going to take a Raspberry Pi, load it with Home Assistant OS, put Ollama on it, run it with a small version of the Gemma 4 free LLM, hook up WakeWord detection, speech to text, and text to speech, and then load a Smart Assistant node. This addresses the same type of privacy problem I covered in my home cloud camera video. You own the hardware, but your data is visible to at least one large company. Who even knows what they're actually doing with it? But whether it's an Amazon Alexa device like an Echo or a Fire TV, a Google Nest or Home device, or an Apple HomePod, there's no denying the popularity of these potentially problematic products. Amazon sold 641 million Echoes as of 2025. Google and Apple have sold millions of units as well. If my phone video is any indication, there are lots of people out there that will swear that their smart speakers are listening to them. The easiest way to make sure that's not happening is to stop using them altogether. And that's fine for anyone that wants to do that, but most people have smart speakers because they perform useful functions. Welcome back to Dad Explains Everything. Today you'll set up Home Assistant with a voice assistant that's completely local. You'll make a smart speaker that never sends any information to someone else's server. Yes, this video will show you how you can set up smart speakers that have local-only operation utilizing an LLM running entirely on a Raspberry Pi 5. You don't have to use a Raspberry Pi though. The best part of this project is that you can use any hardware you want. This is just an example. As you'll see, a Raspberry Pi 5 works, but it's not exactly a world-class experience. So why a Raspberry Pi 5 then? I have a few reasons. 1. I never really understood the appeal of the 8 and 16 gig Raspberry Pi 5s, as I couldn't really think of any workloads that I'd want to use that would take up that much RAM on a device so slow. This project was what I came up with to push the device to its limits. 2. While you're likely to use Proxmox and some higher-end hardware, I think this is a good all-in-one demonstrator for showing how all of the pieces fit. 3. Related to that point, I don't think it's any big surprise that a PC with a beefy GPU drawing 200 to 400 watts can perform well. I think it's interesting to see what performance looks like when you're talking about a device that draws a few watts at idle and maxes out at 25 watts. The Raspberry Pi 5 on my bench today is a Vemico kit. The link is in the video's description if you're interested. In it, you get a Raspberry Pi 5 with 16 gig of RAM, an active cooler, a 27-watt USB-C PD charger, a plastic case, a SanDisk 64 gig microSD card, a USB microSD card reader, and a couple micro HDMI to HDMI cables. Even if the included SanDisk microSD card wasn't slow, which it is, I wanted to use this as an opportunity to demonstrate powering a Raspberry Pi with power over Ethernet and using an NVMe SSD as a system drive. This came up in the Nextcloud video, so I'll cover it today. I got a ZDE kit, linked in the description below, that includes a metal case, a passive heatsink, and a hat that adds the NVMe socket, provides the PoE capability, and includes a fan on the hat for cooling. Since the hat sits over top of the heat-generating components, ZDE decided to incorporate the fan into the hat. The nice part is that there's no separate fan wire to worry about. The hat connects to the Raspberry Pi with the FPC ribbon cable, and I used the Sabrent 1TB 2030 SSD, which required me to install the extra included standoff. Putting everything together takes less than 5 minutes. Like with many of these videos, there's a worksheet for this one too. The worksheet link is in the video description below. This project will be a little different, in that there are multiple ways you can approach this. You don't have to use an NVMe SSD. Because I started with loading Raspberry Pi OS onto the SD card. Once I booted into the Raspberry Pi, I downloaded and installed the Raspberry Pi imager on it. Then I installed Home Assistant OS onto the NVMe drive. You have to list the system drives in order to do this. Be aware that this action will delete all data on that SSD. Once that's done, you'll set the boot order with raspi config. At that point, you can take out the SD card as you won't be using it anymore. You'll connect to Home Assistant with a web browser and finish the initial configuration. It's a good idea to give Home Assistant a DHCP reservation on your DHCP server. That's usually your router. If you followed the Pi-hole or AdGuard Home tutorials, the process for setting up this reservation is the same here. Now that you have a working instance of Home Assistant, you'll load Ollama server by going to the settings, add-ons, add-on store, and you're going to add the Ollama repository by pasting the GitHub link from the worksheet. Once you've added the repo, the Ollama add-on shows up in the store. Install it, start it, and it runs Ollama right on the Pi. Confirm that you trust and check any third-party add-on before installing. This one is a community project and not an official Home Assistant add-on. Next, you're going to go to Settings, Add-ons, and Add-on Store and install Whisper. This is the speech-to-text component. You will select the base EN model, or the tiny EN model if you want to squeeze out just a little more speed. Don't get excited, this only makes the pipeline a couple seconds faster. Then you're going to install Piper. This is the text-to-speech component. You can select the voice you want it to use. Finally, you'll install openWakeWord, which is the component responsible for WakeWord identification. After each install, start the add-on and then go to Settings, Devices, and Services. Each one shows up under Discovered as a Wyoming integration. Click Configure and Submit on each. That's the whole wiring step. The protocol does the plumbing. To wire up the assistant pipeline, you'll go to Settings, Voice Assistants, and create a new assistant. 1. Conversation Agent. The Ollama integration model, Gemma for E2B. First, add the integration under Settings, Devices, and Services, add integration Ollama, and point it to your server URL from A3. 2. Speech-to-text. You're going to select Whisper. 3. Text-to-speech. You're going to select Piper with your chosen voice. 4. Be sure to enable Prefer Handling Commands locally. This isn't the difference between local and cloud processing. It just gives Home Assistant the first crack at determining if the command is for a core function, like turning a light on or off. And just like that, it's done. The Wyoming protocol has really changed the game from the early days of trying to get this stuff to work. The next part is actually doing something useful with the capability that you've just added. Look at this. It's an ESP32S3 Box 3. Instead of spending $50 on an Echo Dot that streams every request back to Amazon and is completely dependent on your internet connection being up, you can use this $50 Box 3 instead. It has a couple microphones, a microphone mute button, a touchscreen, and a stand. It comes with a USB-C to USB-A cable, but you'll need to source your own power supply. The link to the Box 3 is in the description below. As the name indicates, the heart of the device is an ESP32 microcontroller. It can't do much, but it is a pretty effective satellite to your Home Assistant voice assistant setup. To configure the device, you'll plug in the USB-C cable directly into the Box 3 display unit, not to the base, and the USB-A side into your PC. With Chrome, Edge, or any other Chromium-based browser, you'll connect to the Home Assistant URL on the worksheet. Then you'll press the Connect Install Voice Assistant button. When prompted, you'll put in your Wi-Fi credentials. Then you'll add the device to Home Assistant. The cool thing about the Box 3 is that it has just enough horsepower to run the WakeWord process locally. The downside is that it's limited to a few fixed wake words, like, "Hey Jarvis." We installed openWakeWord on the server, so you'll have the ability to set a custom wake word if you want. Now that you're connected, you can select the device in Settings, Devices, and Services, ESP Home. In the settings, you'll set the assistant to the pipeline that you built in A5. Now you're completely done, and it took you less time than watching an episode of Rooster. Hot damn. Hey Jarvis, set rice timer for 10 minutes.
I have set a timer for rice for 10 minutes.
Okay, so this works as a proof of concept. The Box 3 is pretty basic, and the audio is not great. Considering that many people use their smart speakers for Bluetooth or cloud music streaming, I can show you what a louder and higher quality smart speaker setup would entail. And because you know what this channel is like, I'll even show you how to make it. Let me know if you want that video. Running Home Assistant on a Raspberry Pi is fine. While I've shown it's possible, I think I've demonstrated that running a model on Ollama is not really a good workload for the Pi. The Forget video, which is still coming, shows loading Proxmox and Home Assistant. Let me know if you'd like to see Ollama loaded on that box as well, so you can see the comparative performance. With an old Ryzen 7 2700X, but with a decent GPU, you may be surprised with the results. This is what I got for some of the content I like to put out, so let me know if you'd like to see any of those videos. Vemico wanted to show support for the content I'm making, so they provided the Raspberry Pi 5 kit in this video. If you're new to Raspberry Pis, Vemico kits make it easy to make sure that you have all of the components that you need. If you found this useful or interesting, hit like, subscribe, and share this with anyone who's ready to stop having microphones in their house that stream data to other people's servers. If you want to support my work, please hype the video and consider becoming a member. I'm not a big deal, so it's pretty cheap. If you really like what I'm doing, there are expensive tiers too. And speaking of members, I want to thank new members on the screen for their support. Thanks, and have a great and completely private day.